Here's some problems that ask us to use a second derivative test to decide about minimums and maximums. So if we look at number 24, it's probably the easiest one to do right now. So we know that f prime is, using the power rule, is 9x squared minus 36, and then the second derivative will be what, 18x. So then, so what you want to do is look for the zeros for the first derivative. So you're asking yourself, when does f prime equal 0? Well, I'm seeing what I can factor out a 9, and doesn't that factor to x squared minus 36? And then that factors to 9 times x plus 6, x minus 6. So I know that the zeros for this are negative 6 and positive 6. So if I put those into my second derivative, I know f double prime of negative 6 is going to be a negative number, whatever negative 6 times 18 is. So since the second derivative is negative, I know that the original function is concave down, which tells me this place where the slope is 0, right? That's where the first derivative is equal 0. And that will be a maximum because it's concave down. The second derivative is negative. And then with when x equals positive 6, if I substitute in positive 6 in the second derivative, that's a positive number. So that tells me the function is concave down. So when x equals positive 6, this will be a minimum value, and this will be a maximum value. And we do that using the second derivative test. I'm not quite sure where you're at in your derivatives, but if you look at something like number 30, if we want to take the first derivative of that, we're going to use the product rule. So it's x times the derivative of e to the x plus e to the x times the derivative of x, which is 1. And then if we take the second derivative, we're going to use the product rule again. So it's that same x e to the x plus e to the x, and so that's the derivative of the first part, plus the derivative of e to the x is another e to the x. So what can we do here? Well, I see. So for the first one, I want to set that equal to 0. So I can factor out an e to the x. That leaves me x plus 1 equals 0. And since e to the x is never 0, we can ignore that. So when x equals negative 1, that's a critical value, a critical point for the function. And now to use the second derivative to decide whether that's a maximum or a minimum, I'm just going to drop in negative 1. Well, let's see, that's going to be negative x, negative e to the x, plus 2e to the x is going to be e to the e. I'm sorry, I should be using negative 1, shouldn't I be? So e to the negative 1, and another e to the negative 1. So that's going to be negative 1 over e plus 2 over e, which is going to be a positive number, right? So since that's a positive, since the second derivative is positive, greater than 0, this tells me that function opens up at that point, and when x equals negative 1 will be a minimum value. Okay, so that's how you use the second derivative test. We can always do all of this with just the first derivative, but since this is how they're asking us, that's how I determine it. Hope that helps.